Okay, so let's go ahead and get going again. What I'd love to do now is actually move into a little bit of just using a visual programming environment to actually start playing around with parametric forms. So just get a sense of really what it's like and, really, like, it's kind of easy and fun. Hopefully you'll sort of get the same sort of sense about it. And we're going to do something involving just starting with points and playing with points and just controlling your locations. That ultimately is going to lead to playing with objects and controlling their dimensions and the parameters that drive them. But we'll sort of build ourselves up a little bit just to sort of get our feet wet with the Dynamo environment. And the basic tact we're going to be using is we're going to start by just sort of creating some points and numbers to drive the points. Then we'll think about arrays of numbers that work together. So we have a whole series and how we add them together arithmetically and ultimately create lines or drive Revit families using them. So it's kind of a very logical sequence to it. It's just kind of building up from scratch. Okay? And to go ahead and play with this, let's start ourselves off just with the whole notion of how we get going. And the way to do that is if you go on over to Revit or Vasari, either one of those environments will work, and we go to the Add-ins tab, you'll find Dynamo hiding around in the background there since you installed it. And just open it up and we'll take a look at what we got. So what we're looking at right now is called the Dynamo programming environment. There's a kind of preview of what we're doing happening over here. There's a series of different commands. All the different commands are available in the programming language are over here on the left-hand side. Okay. There's the ability to open or save scripts. As we do our work, we want to save them away and be able to recall them. The scripts tend to be associated with a specific Revit file. They don't have to be, but we often kind of create them in conjunction with the objects of a single file. Okay. There are some things happening down at the bottom. There's a run command, or run automatically. That has to do with as we're doing our programming, as we're laying things out, whether you want it to happen immediately as you make every change, or you want to make a couple changes and say run and have it be an explicit step in terms of evaluating things. Okay. So debugging. This whole area over here, this graphical environment over there, you can control. Let me kind of talk about what it does and kind of what's available in there. Under the View tab, you'll see there's this notion of the background 3D preview. You can either have things showing here or not. By default, I like to have them showing, so if that isn't selected, you can go ahead and select that. And as we go through and create points, we'll be able to see them over here. The other thing that's useful over there is this notion of navigating the background 3D preview. And Control-G turns that on or off. Let me show you what I mean. So it's got a little grid over there. And it's, by default, as I go dragging around, I'm selecting. I'm not actually moving that grid. If I go Control-G, the little axes show up. And now, if I right-click, I can pan or orbit. I can sort of move that grid around just so I can sort of see. I can also zoom in and out using the scroll wheel. Okay, but that's only when this navigation mode's turned on. So Control-G turns that on or off. Just so you sort of know about it in the background. What we're going to be doing is we're going to be putting a lot of programming logic on that screen, and you'd like to be able to see the programming logic as well as this little preview of what's going on. So let's pause there for a second. I'm going to Control-G again to turn that off so that I'm back to just sort of laying logic on the screen. Okay, in terms of the logic that we're putting on the screen, over here in the library full of different things, if you go clicking on in and see what's available in there, you'll find just all sorts of stuff in there. Some core things about lists like arrays, about string values, time, all sorts of functions. But let's go ahead, under geometry, you have things about creating points or lines. There's a lot of different stuff in there. But actually, rather than browsing that, what I tend to do is actually just search, because search works really, really well. It pops up the functions pretty quickly. So what I'm going to do is I'm going to shrink that up just a little bit so it's a little smaller on my screen. Okay, so I can make that preview area a little bit bigger. And let's go ahead and get going. Okay, one of the most basic things that we tend to create is just points, just X, Y, Z points. And those are very, very useful for us. And there's a command, point create X, Y, Z.
But if you come on over here to this environment and you just type in point, it'll suggest the things that it knows about. So these are all the different types of functions it knows about for creating points, including down in here, it's point create XYZ. If you wanted to, you could have typed XYZ instead. Okay, and that just gives you some more information about like how we can do those things. Okay, and we can create, spherical coordinates, polar coordinates, a lot of different ways. But when you find the function you like, just click on it. You don't have to double click, just click it, and it'll show up. It'll put what's called a node into the graph. Okay, so we have this XYZ point, and if you want to, you can move that around. Okay, so far there's no values for this XYZ point. I'm not seeing anything just yet. Well, actually, what I need to do is if I want to see it, let me click Run, and you'll see it actually does put a point in there.
Yeah, right now it's putting a point at 0, 0, 0, because there's really no values associated with this. So it's just kind of a
bunch of zeros at this point. What I'm going to do is I'm going to turn on Run automatically, just so as we work, it'll keep on updating very, very quickly and kind of show us what we're doing in the background. But you can do something else instead. Okay, so right now we just have a point, and it's at 0, 0, 0 because there's no values associated with it. If you actually want to see what that node evaluates to, you can actually hover over that little preview, and it'll show you, currently it's set to 0, 0, 0. Okay, so you say, okay, points at 0, 0, 0, okay, but not all that incredibly interesting. Let's go ahead and start adding some more to this. So we would love to be able to go through and start associating values with X, Y, and Z. Okay, and to do that, anytime you want to put some sort of a numeric constant in there, what you do is you can start typing num or number. Okay, we're going to put number, create a number. And I'll put one of those in there. I'm just going to drag it over to the left. Because you're going to see I'm going to visually link these things together from left to right. Okay, so I can put some sort of value in there. For example, if I want the number to be 10, I'll just type it in there. If I want to then link that number to one of the inputs on this point node, what I do is just go dragging from this little arrow right here to the thing I want to input it to. And when I connect those things together, okay, that point's moved to, now it's at 10, 0, 0, because I filled in the value for the X but not the Y and Z. Let's just pause there for a second. Give everyone a chance to sort of get yourself an X, Y, Z point and maybe a number to drive it. Okay, those people doing good? You get anything? Are you good? Your plugger doesn't work? Okay. So, there's always something. No worries. Okay, so we got this number. It's hanging around driving the X right now. I would love to have some other numbers driving Y and Z. If I want to have the same number driving all three, I can actually drag out and just make that same 10 drive the Y and drive the Z too. You'll see as I've done that, the point is sort of moving around in space. So now it's a 10, 10, 10. If I don't want to have the same number driving all three, I just need to create some more numbers. And to do that, I can do it a couple different ways. I could come over and just type num and click number again and get another number node. That'll work just fine. I could also go ahead and just kind of copy one of those, Control C, and paste it, Control V, and get another node. But I really just have 3 number nodes right now. And I can hook those together a little bit differently. Let me hook that one into the Y, and I'll hook that one into the Z. Okay, so now I have 3 that are all working independently. This one's the X is 10, Y is 0, Z is 0. Now, as we're going through and programming our nodes, having nodes label things like number may not be informative. You might want to go ahead and change those to be better looking things to let you know what's going on with your programming. And if you want to do that, what you can do is right click on any of them and say rename it. So I'll say this is the X value. I'm going to change that to the y value, just so I have some sense of what they are, because when this starts getting cluttered, it's going to be a little bit harder to see. And I'll rename that guy down there down to the z value. Okay, so given an x, y, and z, why don't you guys try typing some different numbers in here? So great, if I want that to be a z of 5 and a y of 2, whatever it is that I want to put in there, I'm creating a data point at, or a point at that place. So it all starts with just the whole notion of numbers and putting these values in there. Okay, so far so good? Okay, if that's looking pretty good, let's go ahead and talk about number sliders, because number sliders get a whole lot more interesting. Here's the idea. What we'd like to do is, as opposed to just sort of having a single value, x, y, z, and plugging it in there, which hasn't really bought us much compared to opening up the dialog and typing in numbers and saying apply over there. Yeah, we'd love to have a slider that lets us kind of very dynamically change things around, and let's show you how that looks like. So again, you can just type in num, or you can type in sly, whatever it is. It'll suggest number slider. We'll drag one of those in there. Let's talk about what this node does. Okay, this node has a current value, a low, and a high. So this one current slider is set up to go anywhere from 0 to 100, and the current value is 50. So if I would like to, let me do this. I'm going to just kind of push that number slider up to the top so I can sort of see it a little bit differently. I can take that link and tie it into the x value instead. So as opposed to putting in a single x value, right now I have a slider associated with the x value is going to go anywhere from 0 to 100, and currently it's set to 50. So let's take a look at that. So you can't see it right now because it's almost off the screen. Let me bring the x back in there. There we go. There's x. It's hanging around over there. I can even get rid of that one if I want to. Okay, and if I want to change the range, if I really don't want that to go 0 to 100, just 0 to 20 would be better, something like that. No worries. Kind of move it along, and hopefully the point's moving with you. Okay, so far so good. Okay, so sliders just give you the ability to really quickly start changing things. So thinking ahead, think about that slider being connected to some of those different parameter values on those masses for the height, for the width, for the radius, and how we can start tying those together. Okay, so it starts out, let's just go through and create some sliders, and we can create sliders for different values if we want to. For example, if I want, this is going to be my x values. Let's rename that. I could create, and I could either by typing in the slider again or a control, copy C and copy V paste. I can actually have a Y slider in here too. And again, I'll take that one out. Delete you guys. Now, creating a world with single points at a time may seem like, oh, that's going to be very slow and painful. So you might want to actually start creating whole strings of points at a time that actually have some sort of mathematical relationship to them. And let's talk about how you can do that. For creating arrays of numbers, we have a couple of different functions that are available for you. There's one called number sequence, and there's one that's called number range. And this is that same sort of mathematics that's behind the way we do arrays in Revit, where number sequence is, we go ahead and say that we're starting at a location, we want a certain number of them, and they should all be a certain distance away. So it builds out that way. Number ranges, we're going to give it a start, a stop, and say how many you want in between, and it'll break up evenly between those. Okay, so two different ways of doing it, but it actually works out about the same. let's go ahead and take a look at what that looks like. So coming back over here, let's put in a number sequence as opposed to just having single values. So let's see if we go like, I'll just type sequence. We'll put a node in there. Okay, start amount step. So let's kind of put this all together. Okay, for my start, I can go through and, well, for all these three different things, I could put a function in there, I can put a number in there that's going to drive them. Let me put some number nodes in. So if I want to start at 0, I can put that in there. Let me put another number in here. Copy and paste. I'll put a number in there for the amount that I want every, let's say I want to put 10 of them in there. And I'll put another one, which is going to be the step. And let's say we're going to step every 1. So it's going to increment by 1. So up to 10, or 10 units, incrementing by 1. Okay, let's take a look at what it actually does. That sequence of numbers sort of gives you what you'd expect. Starting with 0, it goes 1, 2, 3, 4, whatever up there. All the way at creating 10 of those. If you wanted to start at 1 instead, you could. If you wanted to have, 8 of them as opposed to 10 of them, no worries. It'll give you the list. So there's the full list. Okay. So here's the deal. If you want to now go ahead and, as opposed to sort of driving the values of an individual point, if you want to have a whole series of different points, what you can do is actually feed the sequence in the XYZ and you get a whole sequence of points. That makes sense? So let me kind of show you what that looks like. So let's say this. Let's say as opposed to X values being controlled by a slider, let me delete that out. We want to actually feed it a whole sequence. So I can feed those into the X values. And let me control G just so I can move that out of the way and you can sort of see it a little bit better. And control G again, turn that off. Okay, so let's think what we got going on here. We have a whole series. We have 8 different points there. Okay, starting at 1, going all the way up through 8. If I wanted to go through and change the increment, I could do that. Kind of spread them out a little bit more further. If I want to change the total number of them, I can do that. Maybe make that 10 again. Okay. What happens is when I feed a sequence in the XYZ, it actually makes, like an array of points as opposed to individual points. So you'll sort of see that what it's created is, based on my sequence, those are all the X values, but the Y and the Z are staying the same. What it will do is it'll pair things in. It'll make as many elements as the maximum driving force is requiring, okay, but it'll sort of fill in the other values. So this is coming because that's fixed, and the Y's would come in because that's currently set by the slider there. But let's think about that. We can go through and kind of combine these together a little bit in slightly different ways. Let me make that a little more interesting as a value. Let me just set that to be 0 right now. I'll put them down on the ground for right now. 0 right there. If we want to also use sliders to drive these, for example, we can. So an interesting thing might be doing something like this. If we take the slider and drop it in over here, can actually let slider drive the amount as opposed to an individual number. Let's delete that. Okay. Now the number of points is actually controlled by the slider, so we can get all the way down to any number of them. Okay, and that number of points is going to be generated for us. Okay, so we're just linking together some logic here. Okay, those are Y's, those are Z's. If we have good programming form, it would be good for us to basically say, that this actually is the number of points. This one over here, what is that? That's the distance between points. I'll just call it the x increment. And that's the start. Okay. So far, so good?
Okay, excellent.
We use the integer slider instead of the number slider to represent the number of points.
That's actually interesting because it always is rounding back to integers. What we almost want to do in here, and it's kind of a good thing there. It is implicitly rounding to integers, but yes,
There should be like an integer slider, right? Let's see what that, yeah, if there's a specific one for that, or, oh, there is an integer slider. Fantastic. Okay, so let's put that one in because that'll be a little more pleasing to our sense of propriety, that actually it's not just truncating the zeros. I love it. Okay, so in here, again, we'll change the upper bound to say 20 points, whatever it is. And now we'll just have these nice discrete increments. That feels a little bit better. Okay, so we're able to kind of control these points. They're not looking too awfully bad in terms of what's going on. They're all laying on the floor right now. If you wanted to go through and have a more interesting thing going on with the points, we can. For example, you might have the number sequence also feeding the y. There's a number of different things we can do that, you know, we'll go through and, well, let's do this. Yeah, that way now. Okay, or we could start creating some sort of interesting
Mathematical relationships. So, for example, if we wanted to go through and create a relationship, right now, like y and z are really just all hanging around at 0, or they could have some specific value.
You know, we could go through and kind of raise that up. That'll kind of change the y, just kind of moving them all the same distance. If we wanted to have, for example,
Points that we're moving so they share the same
xy coordinate, what you could do is instead, or maybe the same xz coordinate, maybe I'll do that, that'll be easier to see. Okay, something like that. We just kind of move them around a little bit. Stop zooming on me. I want to pan. No, I don't want to do that. My whole notion of panning versus zooming is kind of a little messed up in this. Okay, so we can relate them together so they're kind of having the same values. If they have the same values, that's really following a straight line there, just kind of moving up in space. But you'll see the same sort of thing happens here. Let me escape out of here. Right now, it's just the same value for y as for z. Let's go ahead and kind of make it a little more interesting, though, in terms of what's going on. So, for example, let's go ahead and try,
just changing the slope of that line so it's not sort of a one-to-one relationship. Because right now it's the same value for x and for z. And
we may not want to have that. We might want to do something that's a little bit more interesting. So, for example, we can go ahead and add a little bit of arithmetic to this to change it, make it a little bit more interesting. And let's think about the functions you have. You have add, subtract, multiply, divide, trig functions. All sorts of mathematical functions are available to you. And this is where I can actually start getting pretty interesting. So let's think about how we can actually go through and use those. So, for example, we've got a number sequence right now kind of hanging around in here that's going 0 to 20. okay, 20 points, and they're all kind of scaling up one at a time. Let's think about actually going through and, as opposed to having that same series of points feed both x and z, actually putting a little bit of a mathematical difference in there between the two. So for example, this has that current list, 1, 3, 5, 7, 9. Let me put that back to 1, just because it'll be a little bit easier to see what's going on. Okay. Let's tie in a little bit of a mathematical relationship. So for example, if I wanted to amplify, if I wanted to have it be a little bit bigger, what I can do is put a multiply in there. And let's talk about what multiply actually does. Okay. Multiply just basically lets you feed in either a single thing or an array of things, and another number you want to multiply, and then we'll multiply the two together. So let's think how that would be useful to us. What we can do is we can start by saying, let's take that sequence of numbers, that sequence 1, 2, 3, 4, 5, 6, 7, 8, 9, and just link it in as the input to this multiply. Okay. So far there's not enough information there because all it really has is half of what it needs. What we can do is then go through and put in a value that we want to do the multiplication with. So if I put in another num, and let's say we're going to multiply this by a factor of like 3. I'm just choosing that number. We could again put a slider on there. That might even be more interesting to do. In fact, let's do that. Let me go ahead and put a slider in here. I'll put that in there instead of the num. I don't want to be multiplied by a factor of 100, maybe only a factor of 5, something like that. We'll keep it relatively small. Okay, but I'll put that in as the other input to the multiply function. Okay, what happens now is you'll see that that list 1, 2, 3, 4, 5 got multiplied by 5, so now it's 5, 10, 15, 20. Okay, so it's multiplying that all out. And if I want to then use those as the z values, what I can do is take this out of this and tie it back into the z's. Okay, and now what's happening is up here, the z values are all going, they're always 5 times whatever the x values are. So let's think about what the effect of this is. As you're going through and doing this, I can drag the slider down. As I'm dragging the slider down, what I'm doing is just changing the amplification. I'm just changing the amount that I'm going up, the slope of the line really. So again, as I either change the number of points or as I change the amplification, I'm starting to get an awful lot of control over what's going on over here. Now, this all seems pretty primitive. We're just moving points around in space. But when you start thinking about these as being the endpoints of different building elements, the endpoints of different building panels, or just features of a building, it starts to get to be very powerful. So let me pause there for just a second, and just sort of stop and think about, there's this whole notion of this visual programming. This is different. This looks a little bit different than programming in Java or Pascal or Python. There's actually a lot of Python beneath it all, but it really is this whole notion of just tying these different links together where we can control different nodes, link them into different inputs and outputs, and at the tail end you get some sort of result. And this sort of programming, this visual programming, is very similar. You hear it's being implemented in Dynamo. When we look at Rhino, it's implemented in Grasshopper, but it's really the same sort of notion. It's just visual programming is the way to get to this, where you can control things through sliders and nodes that ultimately sort of drive behavior. So let me pause and just sort of ask, how is that part resonating for you? Is that okay in terms of this whole linking everything together as a series? It's kind of like water flowing through pipes or something. You just sort of things flow from left to right. Does that sort of feel okay with a programming paradigm? Okay. It tends to work pretty well for a lot of people, but not everyone sort of gets it at first. But it's if it's feeling good, if you can handle what's going on here, you're going to be golden. Because this is really, it's the basis of really what we're going to be doing kind of throughout the quarter. It's all about just, we'll build more and more complicated networks, but it all really comes with grabbing some different primitives over here, and based on as we learn more different primitives, just linking them together to kind of drive geometry. So that part works out pretty good. Okay, so feeling okay about that? Okay, good. let's go ahead and try some other ones to sort of give us a little more flexibility in terms of what's going on. How about, sines and cosines? Yeah, just all these things that are just kind of straight lines and sliders that are sort of strictly multiplying things together. That's pretty easy. You sort of get that. Let's just think a little more interesting. Like last quarter, someone wanted to have, light shelves or window heights that sort of created more like a wave. Yes, all sorts of interesting organic effects we can try and come up with. And let's think about how you could do that. So one of the functions available to us is the sine function, cosine, tangent, whatever. There's all these different functions available. So let's go for a sine wave. And here's what the sine wave does. The sine basically lets us go through and just take any value and ultimately give us the sine of that value out the backside. Okay, so let's think about how we can actually use that. Okay, we could go ahead and say, let's go through and just grab this sequence of numbers. The 1, 2, 3, 4, 5 are coming out of here, plug it in, and sort of figure out what the sines are, and then use those as the z values. And that would give us some sort of a sine wave. So for every x increment, we'd get sort of the sine of x. Let's try that first as to get going. So I'll say, take those values out, plug them into the sine. Okay. And then I'll take those sine values out, and I'll plug them in as the z. And it's not doing very much right now. Let's think about why that is. Oh, I didn't get it connected. That's why. Okay, you. Out of the way. Okay, so we got a little bit of a sine wave going there for the x values. That's not looking too awfully bad in terms of what's going on. We could go ahead and do a little bit of multiplication if we wanted to go through and have a little more amplitude control in terms of what the sine wave looks like. This right now is just kind of just taking the x values and kind of messing with that. Let's try something a little bit different. What if we actually put a little multiplier in there? And to do that, I'm just going to take this multiplier, I'm going to borrow it, and say that really what I want to do is take these sine values and plug them in to the multiplier, and then take the output of the multiplier and plug it in as the z values. Okay, so what should happen now is, based on as we move the slider, okay, we start getting a lot more control over that and being able to kind of control the amplitude about what's going on. So, that's kind of where we're going with all this. It's really all about adding a little more mathematical flexibility to what's in there, still giving the ability to kind of control the sliders. And what we might want to do just to finish this up is, as opposed to just thinking about everything being just a series of points, we can actually start creating things like lines through points. And let's kind of finish up with that. So the whole notion is this, that I got this fantastic series of points. It's looking okay in terms of what's going on. If I'd actually like to create a line through those that's actually driving some geometry, let's find out how we can do that. And it really comes out of, for example, let me say line. See if I can find line through points. There it is, right down there. And how does that work? If you just take all the x, y, z values out and plug them in, okay, you then start to get that line through them. And the line is pretty simple as an object, but we're going to see next time is how we actually make that not just lines, but start being different values. Okay. To finish up, let me go and do this. Give you one last thing just to kind of think about as we go away today. And I'm going to open up another file just to kind of give you a sense of something I think is really kind of cool. I'm going to say, sure, let's save my changes. Okay, and this is going to be example 1 and I'm going to go through and open up another example just to give you a sense of where this is going to go. And This is a little bit more complicated, but you'll get a sense to sort of see how powerful this can be. It really is all based on the notion of we have a couple sliders that are moving a point.
So the idea is we have a couple different sliders that are controlling an X and Y location for a point. Okay. And what we're going to do is just start playing around with some geometry, but it's actually sort of a very powerful concept. It's something that we call an attractor. An attractor, and you can think about a repulsor too, being the opposite, it's just that based on how close you are to something, okay, the attraction of that thing affects your behavior. And so it's like being close to a magnet and sort of feeling the force of that. And the way this example is set up is a big grid of circles over here, and basically how close the circle is to the point, to the attractor point, okay, the radius of the circle is changing. It's a kind of a cool example if you want to look at like between now and Tuesday, just to try and unpack it. There's a grid, there's some sliders that are moving around points, and then we're computing the distance between the point that's moving around and the grid points, and based on that, going through and just resizing the radius of different circles. But a very cool concept. You can think about this in terms of as the sun moves through the sky and faces different parts of the building, it's the same basic concept that's going along underneath it all. So let's see how it actually works. Let me Control G so I can move on out. Okay, and Control G myself back out. See how this works. So the attractor point is currently right down here. It's at 3030 or 1725. I take that back. It's over here, kind of in that quadrant. If I start moving it around, this is what the power of all this stuff allows you to do. So for example, let me move this X direction. Okay, or let me move its Y direction. Okay. So what's happening is all those different objects are responding to how close they are to the repulsor, or to the attractor. And that's kind of interesting in its own right. So that's out there in the files that you downloaded. So feel free to go ahead and kind of take a look at that between now and Tuesday. We'll take a look at that a little more closely on Tuesday. But another one that you may want to take a look at that's sort of related to it is, and where we'll go Tuesday is, don't do that. In that same Dynamo folder, we have a very similar notion going on with some actual Revit masses, some little cubes. And what we'll do on Tuesday is actually see how we use that same programming logic to actually change the height, width, and the shape of all these different buildings, or something that some sort of cubes that are in city blocks, based on how close they are to different things too. So again, just trying to leverage, the power of being able to kind of do some more advanced programming and resizing, have all that happen automatically for us, so that whatever it is we decide the relationship really is, we can go ahead and adjust all the different blocks mathematically, as opposed to having to go back and adjust all those one at a time, changing and tweaking all the parameters. Okay. So beautiful. Let us adjourn there for today, and on Tuesday come on back and we will continue moving from just moving points in space to actually start to use the same sort of logic, just manipulating all these Revit objects directly.